So they're both dilution, obviously. So this question is actually about dilution because we have this reactant, and then we're going to change the volume of distilled water. Make sense? Okay. So I don't know, can you hear me?
Yeah.
Okay, you can still hear me. All right. Okay, I'm afraid you couldn't hear me just now. Anyway, pure butanoic acid must be kept away from naked flame. Do you know what is naked flame?
Yeah, like.
So basically the fire. Yeah.
Things.
Yeah, the fire is visible. Can you explain why? So this is about safety precaution, right? So why?
Butanoic acid is flammable, I guess.
Yep, so it's to do with the flammability. So it is flammable. So, you know, things which are flammable are not just alcohol. There are some other chemicals which can burn very easily, and therefore you need to keep away from naked flame. Okay. So this thing here, as you could see, this is a solid, and you want a solution. And guess what? It's only, oh, they're pretty stingy actually. Only 1 mark for this. But regardless, I always like to draw diagram. Okay. I don't know about you, Kevin, but I love to draw diagram. I'm terrible artist. I can't draw that well, but I love to draw diagram because I can see. Can you see what I'm talking about now? You have this much concentration, you have this much solid, you just add water, obviously in a beaker, obviously. And then we know if that is true, the mole is the same. So the mole of the solid must be equal to the mole of the solution. I mean, this is probably what you did. And then you get MR of, well, this whole thing. 1, 2, 3, 4, so 4 carbon, 3, 4, 5, 6, 7 hydrogen, oxygen is 2, and then it's like that. Did you calculate the MR already?
I think it was 110.
Sorry, how much again? 110. Yep, that's correct.
110.
Be careful, be careful, be careful. This is all to 1 decimal place. Do you see that?
0.
You see, your calculator doesn't have a brain. Your calculator cannot think. You have to think based on the accuracy of the data. You're not given periodic table in the exam, yeah? So there's CV, there's mass over MR. I need the volume. Here I need the volume of this solution. So I need V. So there's M over C times MR. So there's just 55.0 gram divided by the concentration in mole per dm cube times the MR, which is 110.0. Remember that in this formula, so this thing is in cm cube, but this volume is in dm cube. So this volume here is in dm cube. So your answer is not going to be in cm cube. So you get 0.25. Don't forget unit. I mean, you're a mathematician as well as you do physics. So you know the importance of units, yeah? Do not ever forget your unit. I hope we get 250 cm cube. Okay, all right. So it's 250 because it is cm cube, right? Did you get this because this is dm cube?
Yeah.
Ah, my goodness me! Didn't I just tell you? I just pressed you for doing physics and doing math, and you left your answer as 0.25. My goodness, you lost the 1 mark just like that because you didn't read the question, because you didn't follow the units. Okay.
So I did put 250. I did put 250.
Okay, so that's all right then. Okay. So my press was worth it then. Okay. Anyway, so the next one is, here is the description bit. Now you have a solution, and then what do they want actually? Okay, so you're given this much mass. So this is the solid. So your job really is the solid become the solution. So here they want you to describe making up a stock solution. Remember I talked about this earlier? Do you want to run me through the process? But be careful. Give the name, give the capacity. Basically, whatever apparatus you use, you gotta talk about the capacity of it as a series of number step. Okay, so number 1, number 2, number 3. For 3 marks, there's a lot of lines. Okay, go ahead. So, did you skip this?
So,
so what do you do?
I skip it, but I'll do it right now.
It's all right. You don't need to do any calculation because they already said, oh yeah, the volume calculator in B part 1 was 250 cm cube exactly. So you need 250 cm cube. So what apparatus do you use to make up a solution? What is the main apparatus that's very important?
You put the solid into the beaker.
Okay, so it is already in a beaker. That's what they say. It's given that in a beaker.
And then
read the question.
They get.
So to the way solid in the beaker, what do you do? Come on.
They use the. Pardon?
Well, this is already in a beaker. The solid is already in a beaker. So to the way solid in a beaker, what do you do?
They measure the weight of the beaker and then.
You don't need to because you are already given. You see, you're already given. It's already inside a beaker. You see, you are already inside a beaker. You don't need to weigh it again because it's already given. So once you have this in a beaker, what do you do next? So you gotta follow the story. Where are you now in the story? What do you add to it?
You add 250 centimeter cubes of water.
Mistake. So you have a mistake. Okay. Your goal.
So 50 centimeters.
Your goal is to make it up to 250 cm cube total. Agree? If this is your total, you never ever add the whole 250 cm cube of water. Never ever. You have to add lesser than that. Otherwise, how are you gonna do washing? Otherwise, how are you gonna add more distilled water and do it drop by drop towards the end? So this is your total. You never ever added the whole total. Never ever. If we have 1 liter, then you can add 500 ml. If you have 250 cm cube, I usually would say add 100 cm cube. That should be good enough. Okay. And you forgot something. You say water just now. Water is not going to be good enough. What do you do?
Distilled water.
Distilled water. And then after you add distilled water to it, what are you going to do?
You have the solid rod to stir.
Okay, so use a stirrer, use a rod, glass rod, not a rod. It could be, you don't use a metal rod, right? You use a glass rod to stir, or you say to mix well. Okay, after that, what do you do? Come on. So now you have a solution, right? What do you do with the solution?
You wash the.
But you have a solution, right? After you stir it, do you wash it?
You put more distilled water.
But then if you put more distilled water inside the beaker,
move it into the.
You need to, after you make the solution, you must put it into the volumetric flask first. Okay, so pour, or you can say transfer. Now you have a solution. The solution into the. Do not forget, you haven't specified the apparatus yet. You haven't specified the name and the capacity yet. It's because there's only one apparatus you need. Okay, into the 250 cm cube volumetric flask. Do you see what I've done there? I have specified the name of the apparatus. I have also specified the quantity that I need. Why do I need this quantity? Because the answer given, well, the answer that I calculated here was 250 cm cube volumetric flask. So I use 250 cm cube volumetric flask. After that, after I empty all of these.
Does it have to be 250 or can it be a reasonable number?
Well, can it be 500 cm cube? That's my question. If it is 500 cm cube, would the concentration be valid?
So do you have to memorize the numbers of the different capacities?
No. Can you read this question? This is your required concentration. This is your amount of solids, and this is the amount of solid that you put in, and this is the concentration you want. What is the volume needed to get this much concentration from this much solid? You calculated it. You calculated it based on 100% conversion, basically dissolving all of this into here. You never ever come up with any random stuff. It depends on the question.
Can we use 300?
You can use 300, but there isn't a 300 cm cube volumetric flask. So typically, usually they come in 100. So the one I've seen in my entire life is 100. I've seen 250. I've seen 500 cm cube. And then I've seen 1 dm cube. And then they come in various sizes, 2 dm cube, 4 dm cube. I mean, something sensible. And the biggest I've seen is 10 dm cube. This is what the school technician, the lab technician use when they prepare for a whole school of let's say 100 students. So they'll make multiple of these 10 DMQ, and then they have to mix up everything together. So quite a heavy job, yeah, the lab technician. This is what you do in the lab on your own, just for your own use, individual. This is for the whole school. Now, as for the volume of this apparatus, it really comes down to your desired volume. So as long as you specify the volume of the volumetric flask, then you can calculate the concentration. But this is the opposite. I want the concentration. I don't know what volume I need. So they will give you a nice volume, which will be a sensible volume. They would have a volumetric flask available for that volume. Does that make sense?
Mm-hmm.
So this question has a fixed concentration from a fixed mass of a solid. You're gonna need this much volume of distilled water, and therefore I have to use a 250 cm3 volumetric flask because they did say calculated in B part 1. The more paper 5 that you do, more on making up a stock solution, you will familiarize yourself with some other type of questions where you don't use exactly 250, but this is quite common in the lab. This is what you use in paper 3 as well, yeah? Now, after you do that, then your beaker become empty. What do you do with the beaker then?
Oh, you wash it with distilled water?
Yep, so wash the beaker with small volumes of distilled water. So we only have 100 ml, well, give or take is 100 ml. We don't need a burette for this because we know that we're going to make it out to 250 anyway. So we can use a measuring cylinder or just a beaker to measure 100 cm3, give or take, yeah, with small volume of distilled water. If you're just doing washing, so we don't use a lot. So usually 3 times like 10 cm3 or 3 times 5 cm3 each time. So after you wash the first time, you combine the washing. That is called combining the washings. Where do you put the washing? Do you throw it away?
No.
You combine the washing into the volumetric flask. And after you do that, then what do you do? So now the beaker is clean. So the beaker has no more of the solid remaining. I transferred everything already. But so far I only have 100 and maybe around 150, 130 like that. So it doesn't matter. As long as it's lesser than the total, it's fine. So it's still far from the maximum mark. What do I do next?
Then add more distilled water into the volumetric flask until it's close to 250. And
yep.
then
so into the volumetric flask.
Water.
You got to mention about the drop by drop towards the end, yeah, into the volumetric flask until close to the mark, until close to the 250 cm3 mark, and then you got to add dropwise towards the end. And after that, after I reach the end mark, what do I do?
Oh no, so you put on the
it's called stopper.
What's it called? The lid.
You just stopper,
and then you shake it.
Yep. So what's the purpose of shaking?
To give the solution a well spread concentration. So like
a uniform concentration.
The concentration of the solution is equal throughout.
Basically a uniform concentration, basically to mix well. So basically there's the same thing, not equal, but like what they call is uniform concentration. Okay, so I mean, there's already 1 hour. We can stop here and pick up next time, or we can continue further. It's really up to you. But I mean, this is serial dilution. You should probably be able to do this, I think.